My first computer was a ZX Spectrum, which you might remember from the interactive Black Mirror episode Bandersnatch, in which a bedroom coder tries to make a video game and has a bad day. But the reality is that most days you didn't get sucked into a weird realm of cursed symbols and controlled choices, and the ZX Spectrum was actually really good for bedroom coding, not least because when you turned it on you saw this menu. From here you can load a tape and be playing a video game within later that afternoon. But you can also tab down to 128 Basic and be incompetently writing your own game in moments. The accessibility of programming languages on platforms like this and the BBC Micro and the Commodore 64 led to a bedroom coder scene which spawned the entire British video games industry. Ocean was set up just to publish these bedroom coder games. The Stamper brothers, who created Ultimate and their range of iconic Spectrum games, to be fair, had some prior programming experience, so they weren't the complete bedroom coder archetype, but it's a really good example of where you can go by publishing games on these systems, because when they changed over to developing console games, they changed their name to Rare. You should watch Mark Brown's video for the full story on this, but the gist for our purposes is that the bedroom coder scene didn't last too long. You can make an entire commercially viable game on a ZX Spectrum with a couple of people because the hardware is so limiting you run out of things for anybody else to do. But as computers get more powerful and the Amiga and the Atari start coming onto the scene, you need a team of people, and that needs a budget. Tools like Unity have dragged the balance back somewhat, but still, while the Pico 8 version of Celeste took a couple of people in a game jam to make it, the actual commercially released version of the game took a small but full team. By the time Worms was released on the Amiga, the bedroom coding scene was big enough to be useful for marketing, but the reality is it was a team effort. But that's fine. That's enough. These tools have got us to the point where the reason you can't make a commercially successful game on your own isn't because there's an enormous technical barrier in your way, it's just because it's really hard. And the tools make it easier. And it works. Computers and video games are more complex than they've been at any point in history, but you can still make a successful one with a small budget and a group of friends if you have the passion and the time to dedicate to it. Heck, you can make one on your own. You just probably shouldn't. But I'm not a game developer. I'm a web developer. And on the web, things are a little bit different. If the de facto standard way to make a video game is with Unity, then the equivalent of a web interface would be React. And the normal way to use React is with JSX, which is a kind of JavaScript-like language with some extra XML thrown in for good measure, which has the advantage that it's a bit more compact and easy to read if you're writing HTML-like content in your JavaScript, but it has the disadvantage that you can't actually run it, so you need another program to turn it into something you can run. The normal way of doing that is Babel, a piece of software designed to turn JavaScript into other more different JavaScript. And the normal way to use Babel is as a Webpack plugin. Webpack is the industry standard bundling software, and speaking as a senior software developer with 10 years experience on the web, I don't understand it. At this point you might be thinking that the build process has got a little bit complicated, but don't worry, we've got your back there too. Grunt and Gulp are task runners. They are designed to allow you to run a series of complex tasks automatically and correctly every time using only JavaScript, a programming language designed to run complex tasks automatically and correctly every time, which runs itself in Bash, another programming language which will let you run complex tasks automatically and correctly every time, which itself runs on your computer, which is literally just a task runner. This is the only thing computers do, and we've put one, inside another one. And if you don't like it, you can use Docker, which just puts another entire computer in your computer. Or for a complicated project, several computers. Because why write for one computer which is physically in front of you when you can write for 10 computers that don't exist? Now obviously all of that's quite a lot to set up if you're new to programming. But rather than just not doing it, the web development community has created Create React App, a command line application, because you know how much people who are new to programming love typing mysterious shit onto command lines, which will set up all of this and more so that you can write your very first Hello World application in 1/4 of a gigabyte of the most relentlessly modern development environment imaginable, instead of just opening Notepad and typing Hello World, because the internet runs on text files and you don't have to do literally any of this nonsense. And I can read the comments now from people saying, sure, React's difficult to set up, but once you've done it, it'll save you time. And that's true if you're writing a big complicated app for your company. But if you're just building something for yourself, it's probably just more complexity. The new versions of React use a system called hooks, which is deeply difficult to understand. This is a hook. It creates a variable. It knows which variable you want, even though we didn't tell it, and it knows which instance of the component we're in, even though we didn't tell it that either. How does it know? Magic. I don't know. React doesn't tell you, and it encourages you not to find out. We don't always need this variable. Shall we put it in an if? No. Jail. Jail for mother for 1,000 years. It's against the rules of hooks. Why? Don't know. Magic. React won't tell you. This is a hook. This is another hook that does the same thing, but you don't have to type these 4 characters, except its name is 4 characters longer, so that was fun while it lasted. This is a hook. Use effect. I'm sure that does something. I wonder what it does. It's not clear. Absolute masterclass in semantic naming going on here. Now, to some extent, this is because JavaScript was thrown together in 10 days by one guy who made some mistakes. So for a long time, you did have to use all this weird stuff to fill in the gaps, but JavaScript's been good actually for quite a while now, and we still use it like it's 2010. I still see people using the map function from Lodash instead of the map function that's built into JavaScript and has been for a decade. It's absurd. It's like writing a function that adds 2 numbers together so you don't have to type Shift plus, and nobody would do that. Lambda is an incredibly powerful library that you can use to turn all of your code into unreadable garbage. The idea of it is that you can take its very small simple functions like add 2 numbers and combine them into complex functions, and it works. It's really neat. If you take, for example, the subtract function, you pass it into a flip function to get a backwards subtract function. You then pass in one argument but not the other, take the function that returns, pass it into the map function. That will give you a function that takes an array and subtracts 1 from every element in it. Isn't that clever? Isn't that just so much simpler and more readable than writing .map x to x minus 1? Because it turns out JavaScript already has a way to combine simple functions into complex behaviours, and it's just writing fucking JavaScript because that's what a programming language is. Why is the tech industry so keen to reinvent everything from map functions to buses? And again, a lot of this stuff is useful and has benefits in the correct kind of project where it's relevant. The problem is that people use it for everything. If you think I'm exaggerating, I was once asked to do some work on a corporate website for a large-ish American startup. The website had exactly one interactive element on it, a form where you had to tick a box in order to submit it. The rest of the website was just static text and pictures. It did not need React, it didn't need Babel, it didn't need Webpack, it had all of them. Let me tell you how that checkbox worked.
Why don't we scrape away this mortar here? Slide one of these bricks out.
The form component defined a function to run when you changed a tick box. It stored that in its state and then passed all of its state, whether or not it was relevant, to the tick box. The tick box went into that state object, found the function it was looking for, and called it whenever it changed. This is already bad, but what that function did was to call another more general function that just said, please validate this field, by the way it is a checkbox.
Then using rope weave from strands of this hashing, a kind of pulley system.
That function called another function that said, please validate this field, by the way it is a checkbox, using the strategy validate field by type. No other strategies have been defined, so the next function looked at that and thought, well, luckily they're asking me to do the one thing I know how to do, so I'm going to call this other function that validates fields by type and tell it, by the way, this is a checkbox. How this function is different from the previous function is not clear.
So that when a guard comes in instead of a tripwire, gets laid out.
This function checks that you're asking it about a checkbox, and if you are, which you always are, because again this is the only interactive element on this website, calls a function called validate checkbox, which does nothing. Whatever you pass into it, it passes out, which goes up the chain, until eventually If the checkbox was ticked, we remove the name of the checkbox from an internally stored list of invalid fields.
We put Rimmer in the guard's uniform, he leads us out, we steal some swords, and fight our way back to the bug.
And then we immediately throw the list away and replace it with a duplicate of itself, because otherwise React wouldn't realise anything had happened. And if that list is empty, we enable the submit button, which is bad practice and inaccessible, because if it's disabled, you don't know why it's disabled, you just have to try changing things until it magically turns on.
Or we could use the teleporter.
I replaced all of this code, and I mean this is literally all of the interactive JavaScript on the entire website, with the single word required. Because not letting you submit a form until you've ticked a box has been built into web browsers since the web was invented. What I'm trying to say is that while the tools we use to create video games take a task that is technically extremely complicated, wrangling matrices and physics simulations and lighting and cross-platform graphics card programming, and turn it into something relatively straightforward, the tools that we use to create web apps take a task that is technically just typing things into Notepad and putting it on the internet, and turn it into something very complicated. And I think a reasonable question to ask is, why? And obviously there are lots of reasons, but I think a lot of it is because the web is viewed as higher status than video games. News coverage of video games is sure sometimes hyping up a particular game, but also sometimes it's asking if the art form as a whole is dangerous. If it's causing people to become violent, or if it's changing the way children's brains are wired. This sort of panicky coverage doesn't get afforded to cinema or literature anymore. Whereas the web is kind of king. In a world where humans can literally fly, the word tech has come to mean making websites and apps. And companies that do it are treated as royalty, no matter how much they mistreat their employees or fire all their ethicists or break the law to crush the opposition. The tech industry is viewed as aspirational in a way that working for a video games company very much isn't. The people who are making video games in Unity and the like are doing it because they love it. They want the tools to get them from zero to building a game as quickly as possible and to get out of the way the rest of the time. The people who are making websites at home are doing it to put on their CV. They're doing it to get employment at a tech company. And so even if it makes sense to build a home project in just static HTML, you're going to want to use React anyway, because the point is not to have built the website. The point is to show that you would be a useful employee to a tech company, and that means showing that you understand React. And that's fine. If you want to invest your free time improving your career prospects, then you go ahead, more power to you. But you shouldn't have to. Companies should be willing to hire people who don't know how to use these tools and train them in them. And some are, but a lot of people will think, well, if you don't have these things on your GitHub profile, if you haven't spent your own time becoming good at them, why should we trust you? And you end up with a team of engineers who all kind of look the same and don't have any work-life balance, and it's not good for your product in the long run. The web was designed to be free for anybody to use, and on a technical level it mostly still is. You can just write some code and put it on the internet, and anyone can run it on any platform, on any operating system, on any form factor. It's every bit as accessible as a Spectrum or the Commodore 64 or the BBC Micro ever was. The technical barrier to somebody new coding their own website is zero. The cultural barrier we've erected around it is enormous. So next time you want to do a home project, or if you're a new developer just starting out, you could use React, you could use Webpack, you could use Babel, you could use Grunt and Gulp and all of the rest of it. Or you could use the teleporter.